Even and odd functions. An even function means if you have an f of x value and you switch it to a negative x, when you evaluate, you're going to get the same as if you had used x. Let me give you an example. Think about the function f of x equals x squared. If you put a negative in, you're going to get the same thing because a negative squared is the same thing as a positive. So f of x and f of negative x in this case would have the same value. So that would be an even function. If you have an even function, then that means that it is symmetric with respect to the y-axis. Let me give you another example. If the equation is f of x squared again, let's pick two different x's. Let's try f of 5 and f of negative 5. One's positive, one's negative, and then the same value. So 5 squared would be 25. Negative 5 squared is also 25. So x squared would be an even function. Let's look at an odd function. An odd function means when you put in the negative x, it switches the whole sign. So let me give you an example there. This would be like f of x equals x to the third. If you put in negative x, that will be negative x to the third. Let me show you with a number. So let's say we use f of x to the third again. And this time, let's put in f of 2. So if I use 2, that will give me 2 to the third. If I use negative 2, that'll give me 8. That would be negative 2 to the third. Well, that would be negative 2 times negative 2 times negative 2. 2 times 2 is 4 times 2 is 8. A negative times a negative is a positive times a negative is a negative. So we have switched the sign of the answer. We had positive 8 when we had the positive 2. We switched the sign, we switched the sign. So this would be an odd function. And an odd function is symmetric around the origin. Which means that it is symmetrical with a 180 degrees rotation. So let's look at this. Is f even, odd, or neither? So f is right here, our red graph right here. In order for it to be even, it would need to be symmetrical across the y-axis, which means if I fold it right here, the graph is going to line up perfectly. That's not going to work. In order for it to be symmetric around the origin, I would need to be able to rotate this figure 180 degrees and have it look exactly the same. Does it look the same? It doesn't look the same. So it's not symmetric that way either, which means that this is a neither. And it's neither because it doesn't match our symmetry around the origin or across the y-axis. Let's look at the next one. Is G even, odd, or neither? So G is this one right here. It looks like if I were to fold this, it would match. So this one's going to be even. And it's even because it's symmetric across the y-axis. So that'll work. Draw an example of a function that is neither odd nor even. Well, we already have that from function f, and we have an even, but let's see if we can draw an example of a function that is odd. Because we don't have an example of odd yet. So let's draw an example of a function that is odd. Odd means it needs to be symmetrical with respect to the origin. Well, I'll draw a quick axis right here. And if it's symmetric with respect to the origin, then what we have in this quadrant needs to match what we have in this quadrant. And similarly, what we have in this quadrant needs to match this quadrant. So let's see what we can draw here. How about something like this? Bump up, squiggle, line. And then if we want it to be symmetric around the origin, bump, squiggle, whoops, let's make it a little bit better than that. There we go. There. There's our sketch of something that would be symmetric around the origin. And that would make it odd. If the point 5, 3 is on the graph of an even function, what other point must also be on that graph? Well, an even function, even is symmetrical with respect to the y-axis. So even means that if you put in the negative, you're still going to get the same answer out. So if I put in the negative, the opposite sign, so in this case it was 5, so -5, we're going to get the same answer out. So if it was 5, we're going to switch to -5, and it will still be 3. If the point 5, 3 is on the graph of an odd function, what other point must be on the graph? Well, that one said that if you switch the input value, it switches the output value. So 5, 3 would be like right here. So if we switch the input value sign, so it was positive, so it's going to switch to negative, then it switches the sign of the output value. So if 5, 3 is on the graph of an odd function, so is -5, -3. Now let's determine if these are even, odd, or neither. So to check that out, we need to put in the reverse. So we have f of x. So let's check f of -x. So that would give us -x squared over -x to the 4th plus 1. A negative squared is positive. A negative to the 4th is a positive. So when we put in the negative, we got back exactly to where we started. That means this one is even. Let's see what happens for part B if we put in a negative. So what are we going to get if we try to figure out f of -x? Well, that'll look like -x and the absolute value of -x. Well, the absolute value is going to take it to positive. So -x, and then this would just be x. So this looks like it's going to give us negative, and then we have our x, and our absolute value x would still be the positive here. So this one looks like when we put in the opposite sign, we got the opposite of the result. So this one will be odd. Let's try part C. So we need to put in our negative. So 1 plus 3 -x to the 3rd minus -x to the 5th. So 1, and then our -x to the 3rd, that will give us -3x to the 3rd. And then right here, our negative x to the fifth. And then we have a negative. So positive x to the fifth. Let's see here. Now be very careful. The sign changed right here and right here, but it did not right here. So I don't have the opposite of everything because there is no sign change right here on the 1. So this is a neither.